Students, welcome back to the discussion on the chapter Electrochemistry, and in this module we are going to discuss about lead accumulator. Now students, lead accumulator is actually also called as lead acid battery or lead storage battery. Okay, now getting to the discussion of its construction, it consists of a container having 38% H2SO4 as the electrolyte. This H2SO4 has a specific gravity of 1.28. The anode here is nothing but the lead plates which are arranged in alternate manner. Cathode here is nothing but lead coated with PbO2. Alright. So that is a very simple construction of lead accumulator, wherein a container consisting of 38% H2SO4 in which you have alternatively placed anode and cathode. Alright. So now we are getting to the discussion on the working part of it. Now let us understand what exactly is happening at the anode. The anode is made up of Pb which gets oxidized, alright. So basically Pb gets oxidized to Pb2+. It enters the solution which combines with sulfate ions, leading to formation of PbSO4. Now this PbSO4 is actually solid in state. In short, it comes out of the solution, precipitates out of the solution and gets deposited over the anode, alright. Similarly, at the same time, the electrons will flow from anode to cathode, which will be accepted by PbO2. So PbO2 here will take up the electrons but in presence of H plus ions. So 1 mole of PbO2 will require 4 moles of H plus ions for its reduction. So PbO2 will get reduced to Pb2 plus ions, alright, with formation of water. So Pb2 plus ions again here will combine with sulfate ions so that PbSO4 will be formed, which will get deposited over the cathode surface. Alright. So I hope students you have got a clear understanding of the mechanism part. So let us actually understand the reactions here. Anode reactions. Pb gets oxidized to Pb2 plus, leaving behind 2 electrons, right? These Pb2 plus ions will combine with sulfate ions, giving rise to PbSO4. So if I write the net reaction here, it is Pb plus sulfate ions giving rise to PbSO4 plus 2 electrons. That is the oxidation reaction taking place at anode. Similarly at cathode, you have PbO2 taking up 2 electrons in presence of 4 H plus ions, giving rise to Pb2 plus 2 H2. Alright. These Pb2 plus ions will again combine with sulfate ions, giving rise to PbSO4, which is actually a precipitation reaction. So if we add these two reactions, we get the net cathode reaction, which is PbO2 plus 2 electrons plus sulfate ions plus 4 H plus ions, giving rise to PbSO4 plus 2 H2O. Alright. So these were the reactions taking place at anode and cathode, right? So if we add these two half reactions, we get the overall cell reaction. So Pb plus PbO2 plus 2 H2SO4, which is actually a combination of 4 H plus ions and 2 sulfate ions, right? Giving rise to 2 PbSO4 plus 2 H2O. Now students, if you have a close look here, the Pb and PbO2 are getting converted into PbSO4, and at the same time H2SO4 is getting consumed. It is getting used up into the reaction, and because of that its specific gravity decreases. And when its specific gravity decreases to a value of 1.12, the cell will stop working and it needs recharging. So precisely, even before it reaches to a value of 1.12, we need to recharge this particular lead accumulator. Alright. So let us understand what exactly happens during recharging. First of all, we are able to recharge the cell when they are connecting them with the source of external EMF, having slightly greater EMF than the EMF of a cell. Alright. And because of that, the polarities will be reversed. So the anode will become cathode and the cathode will become what? Anode, isn't it? So let us have a look at the reactions. The reaction which is taking place at anode is actually the reverse of the reaction taking place at cathode during discharging. Okay. So the reaction is there in front of you, PbSO4 plus 2H2, giving rise to PbO2 plus 2 electrons plus sulfate ions plus 4H plus ions. Okay, that is a reaction taking place at anode. Similarly, at cathode you have PbSO4 plus 2 electrons giving rise to Pb plus SO4 2 minus. Alright, that is a reaction taking place at cathode. So if I want to write the net reaction here, 2 PbSO4 plus 2 H2O giving rise to Pb plus PbO2 plus 2 H2SO4. So here you can clearly see that PbSO4 is getting consumed. It is converted into Pb and PbO2. At the same time, H2SO4 is regenerated, and because of that, its specific gravity will keep on increasing, right? And when it reaches to a value of 1.28, we can say that the cell is fully charged, right? And the EMF of this cell here is actually 2 volts. The cell here is consisting of one anode and one cathode, having the EMF of 2 volts. So if there are 3 anodes and 3 cathodes connected alternatively, we basically have 6 volts battery which is there. Alright. So that was with respect to the discharging and charging of the lead accumulator. Getting into the discussion of its representation. Okay. So anode representation here is Pb solid in direct contact with PbSO4 solid, in direct contact with H2SO4 38%, right? That is the representation of anode. Let us continue with the representation of cathode. H2SO4 is in direct contact with PbSO4, which is in direct contact with PbO2 solid, which is in direct contact with Pb solid. Alright, so anode is negatively charged and cathode is positively charged, right? There is no double vertical line here introduced because all the cell contents are in direct contact. So finally, getting the uses, it is used in laboratory as a source of direct current, in automobiles and also in inverters. So I hope students you have got the clear understanding of lead accumulator. Thank you.
थैंक यू बोल दिया उसने.